Good morning, all. For the coming session, I'm going to discuss the details of oscilloscope and how we use that. I will show close. You can find there are two channels available. I zoom and you just see. You can see one channel is highlighted and the other is dormant. And that is why I said this is channel 1 and channel 2. And that is why you might observe there are two input ports also, one here and the other is connected. So there also we have seen it is written channel 1 and channel 2. And now let me show the display. The display has got two axes. One is x-axis and the other one is y-axis. It's just like a graph paper. And for settings, you will observe the center line is not in, in line with the yellow line. So that is why we have to adjust. How we adjust? You just see. This is called vertical adjustment. And similarly, there is another horizontal adjustment. And now I will connect to the transformer output and you will see let me connect permanent. And you are observing, yesterday also I have shown, today also I am repeating. The sine wave function has been displayed here by the oscilloscope. And now we will go for another test for DC test. Say, let me switch it off. And that DC test, let me select one function. I change the channel now. I select channel 1. And here you can note there is a parameter reading. I'll show you. It is mentioned SC. And you just observe, I zoom it. When I press this function switch, it is changing and now it shows ground. And when I again press, it is called DC. So if you want to measure the DC curve of a battery, let us see how does it respond. And here you can know 500 millivolt. Say it is up to 10 volt. You can see when I touch the terminal, this x-axis shifts a little up. You can see it shifts better now. And the moment I disconnect the DC source, it returns back to the x-axis. Please observe again, when I touch the positive terminal of the battery to the probe, you can see what I'm doing here. I can show you. I have the probe connected to the negative, and now I connect it to positive. And you see there, the horizontal line goes to a little high. That means this is the DC curve which we have discussed yesterday also. It is totally straight. But alternating current is somewhat a sine curve. Now, what are the other parameters we will discuss today for the smoothing of the filter circuit? This I will do tomorrow, but today I plan it, so I have to show it everything to all of you. This is a transformer, and I zoom it, you can see this is the 0 and 12 terminal of the transformer, which is a step down one. And tomorrow, because today I got prepared, but my filter circuit, rectified circuit, burnt out. So last moment I could not do anything. But anyway, I promise tomorrow I will go for again. So this is 0 and 12 terminal. And I have connected two wires, these two terminals. And whenever AC, that means pulsating DC, containing some components of AC, will be allowed through these. We will observe again through the oscilloscope. The graph will change a lot. So this component, remember, is called an inductor. In the filter circuit, this is called a choke coil. And this choke coil, why it is called choke coil? it chokes the AC component passing through, but it is allowing the DC component to pass through. So that I will show, maybe now also I plan to show it a little bit. Let me check before all of you. So what I'm doing, I have to connect the probe of the oscilloscope. Say for example, we are having lamp. I'm showing you, I'm connecting before all of you. I'm having a lamp, but this lamp will not work now, and we will see using a filament lamp. So what I'm doing, I connect on this breadboard this filament lamp, and thereafter the negative, say here, and then I will connect through this transformer terminals, and I will show you if possible using this. You can see at least first demonstration, let us continue with, and then I will show you what is the next item we are going to present. This is a beautiful demo, rather I will keep it here so you can go through it comfortably. I will connect through this transformer secondary, remember. So this is very important observation, and I will place my transformer also on the top. No problem. This is my power source, so that you can see I little shift it. So what I am doing, first I show you and then we'll try to see it by oscilloscope. I power it on, and now I connect this 12 terminal and 0 terminal. You can see when the current passes through, whether it is absorbed or not, let me check. Yes, observe the lamp please. When I connect using this transformer, you can again check. It is not glowing at all, very feeble. But if I remove this, and you can see, suppose I am connecting to another wire directly to the AC source, you will observe the lamp is fully glowing. This is 12 and this is 0. This is fully glowing. Remember. But when I introduce this component, the AC factors, that means alternating current factors, are getting choked. And that is how the lamp did not glow fully. It was partially glowing. I repeat again this particular test. This is very funny. I connect before all of you. This lamp will be connected using a step down transformer secondary section to the source of 0 and 12. That is observed or not. Let me check again. It is glowing. But you see the glow, it is drastically low. That means whose effect is this? The answer is the choke coil. Because it is full AC, so it is choking almost 90%. Similarly, you think tomorrow you will engage it. If you are using it on a pulsating DC using a rectifier, you will find the ripple factors would be almost reduced. Along with a capacitor, you can see this one also used in filtration circuit. So like this, two capacitors are needed to filter. How will be they connected? I will discuss tomorrow. We'll do it. One capacitor will be placed parallel to the load before this inductor coil, and one capacitor, the other one, will be placed again across the load parallel, that is after the inductor. That means this is called a pi filter. See, the symbol pi represents two parallel arms and they represent two capacitors, and the upper arm represent the choke coil. So by that way, the circuit will be a perfect, almost 99% perfect DC circuit. So with that, I come to the end of this session today. I show you again, I repeat before closing, how is the AC ripples and how is the DC ripple. Now first let me show you DC again using this battery. You remember this is negative and this terminal is positive. So your black probe should be connected to the negative and this red one will be connected to this, and you just see the center line, that means the x-axis shifts to another point and that indicates the voltage factor of this source. And if you want to measure AC, again I tell you, you have to change this DC reading here to AC, and let me connect, and you see when I connect the probe to the terminal of the, and I shift this 10, 20, and I connect 0 and 12. Let me cross check. So with this, at least I'm satisfied that we could discuss many components of the oscilloscope and how we adjust it. See this gap, you can adjust it depending upon the time factor. You can make it wide, you can make it close. So this is a very interesting device. For your information, I tell, yesterday I have uploaded in a short video how the ripple factor is reduced by engaging a capacitor across the load. If you are interested, you may go through that. And please get ready tomorrow. I will be ready with all my arrangements. Today, because of that in time failure, I may be excused. So we'll have another session tomorrow. Thank you.